Hello everyone, welcome to the combinational and sequential design practical series using SimulIDE. In today's session, we will study about implementing encoder, decoder, multiplexer and demultiplexer. So let us start with the encoder. So this is the logic diagram of an encoder. So here we have numbers from 0 to 7 on the left side, they are the inputs, and at the output we have y0, y1, y2 as the outputs, and we are using 3 OR gates. So how the encoder works, it encodes the given number. So whatever number we are presenting, it gives the code of that particular number. So suppose if we input 7, so if the numbers, as you can see, from 0 to 7, they can be at logic high or logic low. So if we pull the number 7 at logic high, then it will produce the code for 7. If we pull the input 6 as high, then it will give the code for 6. Let us see the working. So before starting with the working, this OR gate, the output, we must understand how the OR gate works. The output of OR gate is high when even a single input is high. So output is low when all the inputs are low. That is the condition for OR gate. So if a single input is high, output becomes high. So suppose if we pull up this particular 7 as 1, if we make this input as 1, so this 7 input is connected to all the gates, as we can see. So all these inputs become all the inputs become 1, which are connected to 7, and this 7 is connected to all the gates. So even if we pull this 7 as 1, all the logic gates will give output as 1. Okay, so we get output as 1 1 1. So as we know, the code for 7 is 1 1 1, so it gives the code for 7. Now suppose if we pull this 6 as 1, okay, so it must give the code for 6. So this or this 6 is connected to the OR gate, the first and the second, the upper first and second one. So only this 2 will become high, and rest the other y0 is not connected to 6, so it will become 0. So we get output as 1 1 0. Now 1 1 0, of course 6 is 1 1 0. Then let's the last example, let us take this 4. So if we pull up this 4 as 1, now because of this, only the upper gate will become 1, because this 4 is only connected to the upper OR gate, and the lower 2 gates are not connected. So the output will be, of course, 1 0 0, and the code for 4 is 1 0 0. So this is true for all the other inputs as well. Now let us see the working of decoder. Now decoder is opposite of encoder. So here we have 3 to 8 decoder. So input is 3, output is output. There are 8 outputs. In the previous case, I forgot to mention, it was 8 to 3 encoder. Okay, so now here what this decoder will do, we give the particular code to the decoder. Now it will tell which number the code belongs to. So it works opposite to the encoder. So in the previous case, when we gave input as 7, we got the code as 1 1 1. Here it will be opposite. If we give the code, it will give the number. Now let us start with 1 1 1. Okay, now here we are using AND gate. So output of AND gate is high when all the inputs are high. This is the condition for making the output of AND gate as 1. So in this particular case, when we give this all as 1 1 1, what happens, that you can see the green line. So these are the only green lines which are actually connected to the last AND gate, which will become 1. Rest in all the other AND gates, as you can see from this y0, y1, y2 up to y6, in all these cases at least one input is 0 because of this particular input 1 1 1. So at least one of the input is 0. This only the last AND gate is the one where all the inputs are high. So therefore we get this as 1 and rest all as 0. So this is what we get. So y7 becomes 1, which shows that 1 1 1 is actually 7. Okay, so we get 1 1 1 is equal to 7. Now let us take another example, 1 0 1. Now with this input as 1 0 1, what happens is that, as you can see, 0 here, 0 is low, but when it passes through this NOT gate, it becomes high. And in this case, there is only one AND gate for which all the input becomes 1, which is this one. Okay, y5, as you can see. This is the only AND gate whose all the inputs are high. Rest for the other AND gates, at least one input is low, therefore all the output becomes low, and only high is for Wi-Fi. Okay, rest all inputs, let's all outputs are 0. So this is the code 101 is equal to 5. Okay, so this is the number for this 101 code. So this is the decoder. Now let's take the last example, 0 0 0. Now for this 0 0 0, what happens that this 0 0 0 will, of course, when it is passed through the NOT gate, this all input becomes 1, and there is only one case, one AND gate for which all the input becomes high, that is for Y0 output. Okay, and this becomes high, and rest all the cases at least one input is 0. So this is the 0 0 0. So the code 0 0 0 belongs to the number 0. So this is how the decoder works. Now let us see the working of the multiplexer. So multiplexer here will see 4:1. Okay, so this is the logic diagram of a 4:1 multiplexer. So here we are using 4 AND gates, and then finally AND gate, sorry, NAND gate. We are using all the entire, we are designing this using the NAND gates. So S0 S1, as you can see, these are the select inputs, and A B C D, they are the inputs. Okay, and these are the select inputs. This A B C D are the input lines, and Y is the output. So what the multiplexer does, multiplexer is multi input and single output. So this particular circuit will select a single output from many of the inputs. So if we make this S0 S1 as 0 0, A gets selected, so we get A as the output, and so on. And for 0 1 we get the B, 1 0 we get C, and 1 1 we get D. Let us see how it works. Now before understanding the working of NAND gate, we must understand that output of NAND gate is high when even a single input is low. Okay, output of AND gate is high when even a single input is low. So if in a single input, so in this case for the green NAND gates there are 3 inputs. So if a single input becomes 0, output becomes high. We don't need to see the other inputs. But if all the inputs are high, then only the output becomes low. So to make the output of NAND gate as low, all the inputs should become high. Now let us start with the case when S1 and S0 both are 0 0. Now with this 0 0, the lines which are directly connected to S1 S0, they will become 0, and which are connected to through the NOT gate, they become 1 1. Okay, so because of this, what we get is, as we can see in the upper NAND gate, this becomes this 1 1 1 0. They are because of the select lines. So this is 1 1, this is 1 0, is 0 1, and this is 0 0. So in these 3 NAND gates, at least one input is 0, so they directly become 1 1 1. Okay, so the output of this 3 NAND gate become 1 1 1, irrespective of what B C and D are. Okay, but this NAND gate, we can't tell what the output will be. The output will depend on A. Okay, so see, let us see what happens if we make, so this B C D, they are irrelevant in this case. When the select lines are 0 0, B C D become irrelevant. Okay, now suppose if we make A as 0, now because of this 0, the output of the upper NAND, this one becomes high, because one of the input is 0, so this becomes high. Now all these inputs are 1 1 1 1, so all the inputs of this last final NAND gate is 1, so the output becomes 0. Okay, so this all are 1 1 1, so it becomes 0. So what we see is A is 0, Y is 0. Okay, now let us take suppose we assume, now let us take A as 1. Okay, now what will happen, all the inputs of this NAND gate, the upper NAND gate, are 1 1 1. Okay, all are high, so output becomes, okay, so this one, so output becomes 0. Now even a single input becomes 0 of this NAND gate, the output becomes high. Okay, so what we see is A is 1, Y is 1. So when the select line, so what we conclude is that when the select lines are 0 0, A gets selected. So if A is 0, Y is 0, A is 1, Y is 1. So we can show it further that when the inputs are 0 1, B gets selected. When the inputs are 1 0, C gets selected. When the inputs are, when the select lines, sorry, are 1 1, then D gets selected. So this is how the multiplexer works. Now this is the another example of IC 74153. Now IC 74153 is a multiplexer IC. There are two multiplexers. So you can see here one multiplexer is x0, x1, x2, x3. One, that is 1 x0, 1 x2. So this is one multiplexer, output is here. This is another multiplexer and output is here. So this is dual 4:1 multiplexer. A and B are the select lines. So if this is 0 0, if we make A B as 0 0, x0 from here and x0 from here get selected. If we make it as 0 1, sorry, in this case actually B is the most significant bit and A is the least significant bit. Okay, so when we make it as 1 0, x2 and x2 get selected, and this E, they are the enable lines. They must be always connected to 0. I'll show the working using SimulIDE. This is another multiplexer. This is 8:1 sorry, this you can see there are 4 multiplexers, 4 2:1 multiplexer. So this is one multiplexer having input as B3 A3, then another multiplexer having input B2 A2, then the B1 A1, then finally B0 A0. So this Y0 is output of A0 B0, Y1 for A1 B1, Y2 of A2 B2, Y3 of A3 B3. This OE is the enable line. This must be always 0. This select line, this one, it can be 0, it can be 1. If it is 0, any of this will be get selected. Will get select. I can, if we make this as 0, this A3, A2, A1, A0 gets selected at the output Y0, Y1, Y2, Y3. And if you make it as 1, then B3 from here, B2 from here, B1 from here, and B0 from here they get selected. Now let us see the working of a demultiplexer. 1:4 demultiplexer. So demultiplexer is opposite of multiplexer. So in multiplexer there are many inputs, one output. In demultiplexer we have single input and many outputs. So on the difference you can see here we are having AND gate, simple AND gates are there. Okay, and this is a single input I. Okay, this input is connected to each and every AND gate. And as you know, for AND gate, if all the inputs are high, then only output is high. So let us see if the input, this select line, suppose if we make it as 0 0, what happens is that the first AND gate, this input, out of the 3 input, this is 1 1 because of select lines. This is 1 0 0 1 1 and this is 0 0. So these are the inputs because of the select lines to the AND gate. Now in this 3 lower AND gates, you can see there is at least 1 0. So output Y0, the output of this Y1, Y2, Y3, they become 0. Okay, but this Y0, it depends on I. Now this output Y1 of Y1, Y2, Y3, they are 0 irrespective of whatever input we are giving, but Y0 depends on I. Now suppose if we make it as 0, so this is 0, so if a single input becomes 0, output becomes 0. Okay, now suppose if we make this I as 1, now here all are 1, so it becomes 1. So as we conclude that whatever input is there, it comes at Y0. So when select lines are 0 0, this input appears at the first output. And if we make it as 0 1, we can show then if it is 0 1, the output will appear at Y1. If it is 1 0, it will appear at Y2. If it is 1 1, the output will appear at Y3. We will actually verify this. Now this is IC 74139. This is a demultiplexer IC. So here there are 2 demultiplexers actually. Okay, so this is Y00, 01, 02, 03. This is one demultiplexer. So this is a dual 1:4 demultiplexer. So here there is another demultiplexer, you can say. So this enable should be pulled to 0 and this enable should also be pulled to 0, and if this is 0 0, so this is 0, this becomes 0 0, and you can see there is a bubble here output at the output. The bubble shows that it is actually active low. So whichever output gets selected, it becomes low and all the other they become high. So if we make this inputs, this A0 0 0 and 0 1, if we make both as 0 0, then this Y0 0 will become high, become low, and all the other this 3 they will become high. We will see this working. Now in the last part of the practical, we will see how we can implement expressions using multiplexer and demultiplexer ICs, and then we will jump to SimulIDE for performing the practical. Let us first understand the multiplexer IC. So this is how we have the multiplexer IC, and these are the input lines. So we are using 8:1 multiplexer, so there are 8 inputs and 1 output. So these are the input lines, there are 8 input lines. And then we have the, you can see the select lines, there are 3 select lines. So why there are 3 select lines? Because 2 raised to 3 is 8, therefore we need 3 select lines to select any of these inputs. Then we have only one output line. So this is the multiplexer, many inputs and single output. So how does it work? Let us see how it works. So suppose if the select lines are all 0 0 0, so 0 0 0 is actually 0. So what will happen here? Whatever input we are having at this 0, okay, because there are 8 inputs, so only one input will go to the output end, output line. So at this case, because it is select lines is 0 0 0, so 0 input is selected, which we get at the output. Now suppose if the select is 1 0 0, so 1 0 0 is 4, so this input 4 is selected to become the output. So whatever input we are having at 4, it will appear at the outputs, because only one input can be selected out of 8. So with 1 0 0, the input at 4 is selected. Now suppose if we make it as 1 1 0, so 1 1 0 is 6, so this input is selected. So whatever input we are having at 6, we get at the output end. Now how to convert this multiplexer IC to implement an expression? So we have this expression like f of ABC is sigma small m 0 2 5 7. So this small m indicates it is the SOP expression, and we need to make this 0 2 5 7 to high and rest all to 0. So this is how we do this. So if we are given this expression, the advantage of using multiplexer is that we don't need to reduce it. We just connect this 0 2 5 7, as you can see, to logic 1 and rest 1. So you can see this input 0 1 2 3 4 5 6 7. So this inputs out of this 0, this what is it, 0 2 5 7, they are connected to logic 1, and the remaining lines they are connected to logic 0. So whatever input line we give, we get output only for 0 2 5 and 7. So if this input is 0 0 0, so this will come out and we get high. So we get high only for this particular inputs and not any other. Now next is demultiplexer IC. So even demultiplexer IC can be used to implement the expression. So this is the demultiplexer IC 1:8. So demultiplexer is opposite of multiplexer. It has one input and many outputs. So in this case we have one input and there are 8 outputs. So these are the output lines. There are 8 output lines, and here also we have select lines as 3. There are 3 select lines because 2 raised to 3 is 8, and there is only one input line. Now this, how this works? Suppose if we make the input select, suppose we make the select lines as 1 0 0. So 1 0 0 is of course 4. So in this case, whatever input we are giving, that input appears at number 4 line output. So if we make select lines as 1 1 1, 1 1 1 is 7. So whatever input we are giving, it appears as output at the 7th line, 7th output line. So this is how the demultiplexer works. Now how do we implement this function? Now the advantage of demultiplexer is that we can implement multiple functions. So here we implement 2 functions, f1 ABC is sigma small m 0 2 4, and f2 of ABC is sigma small m 1 2 5 6. So this is the required diagram. As seen in this, we are using 2 OR gates. So if you want to implement 0 2 4, so this you can see the blue line output, they are connected to this OR gate, and we get this output y1 for this function. And for the other function we have 1 2 5 6. So this red lines, they are 1 2 5 6, they are connected to another OR gate, and we get the next output. So whatever select lines we give, this particular functions, the output are selected, we get this here. So this is how this demultiplexer can be used. Now let us perform this using SimulIDE. So now we are in the SimulIDE. I will go on designing the circuits one after the other. We start with the encoder, then decoder, then the ICs, then the multiplexer, then the ICs, and so on. So I'll go fast because the video is already too much long, so to save the time. Now let us verify the working. I'll just turn this simulation on. So this is the first one is the code for 7. So if I make it as 1, so this is 1 1 1, so 7 is 1 1 1. Now if I make it as 6 as 1, so this is 1 1 0. For 5 we have 1 0 1, 4 1 0 0, 3 0 1 1, 2 0 1 0, 1 0 0 1, and this is 0 of all are 0 0 0. So this is how the encoder works. Now let us go for the decoder. Now after making the circuit, let us verify the working. I'll just turn this on. So with all 0 0 0, this 0 gets activated. For 0 0 1, okay, we get this is output is 1. For 0 1 0, we get this as 2. So this 0 1 2 3 4 5 6 and 7. So this is the 0 1 0 is code for this, the 2, and 0 1 1 is 3, then 1 0 0, this is 4 5 and so on. So if you make all as 1, the last one gets activated. So this is how the decoder works. Okay, now let us go for the multiplexer. Now after designing the multiplexer, let us understand its working. So we just turn it on. So the select lines are 0 0. So for 0 0, what will happen is, if we turn this on, we can see 1 1. For 1 we are getting 1 output. For this 0 we are getting 0. So out of this 4, if I turn this on and off, this turn on and off, this it won't give any effect at the output. This 3 are not selected, but this is selected for 0 0. Now we make it as 0 1. So for 0 1, this is not selected, but this is selected. If this is 0, output is 0. This is 1, output is 1. Now for 1 0, this is not selected, this is also not selected, but this is selected. Okay, so out of 4 only 1 gets selected with this select lines. So on this both are 1 1, so now this will get selected, rest all will not be selected. So this is how this multiplexer works, 4:1 multiplexer. Now let us design this part. We just make some changes to convert this into a demultiplexer. Okay, so in demultiplexer we have 4 AND gates only, and we have 4 probes, and we only have 1 input. So I'll just remove all the unnecessary components, just remove this part. Okay, I'll just delete it. Okay, and then this, we don't need this. Okay, I'll just remove this. Then okay, then I'll just turn this 0 0. We don't need this now. And then this are actually in the previous case we had this as a NAND gate. We need to convert them to AND gate. Just double click here, and invert input, we just uncheck this invert input so that it becomes a AND gate. So we need to make it as a AND gate, and this also as AND gate. Now there is a single input. We need to connect all this, the third input of all the AND gates, to this input, and we need, of course, 3 more probes. We already have 1 probe, we need 3 more probes, so we need 4 outputs. So this is the second one, the third one, and the fourth one. We need 4 probes. So just connect this. So this gets connected here, this gets connected here, this, so this is the connection. Now let us start this. So with select as 0 0, what we observe is that this is 0. So this input, there is only single input, there are 4 outputs. So this input is directed towards the first output. Okay. Now if I make it as 0 1, now this input is directed towards the second output, as you can see, and with 1 0, this will be directed towards the third output, and with this 1 1, this will be directed to the last output. So this is how the demultiplexer works. Now let us study the ICs. Now let us study the working of the IC 74153 and 157. So in here, search components, I can just type 153 and enter. So this is 74153 IC. Okay, we can even go in this option IC 74 and we can get this IC from 7400 series. So this is the 74153 IC. Now how to do the connection in this case? So we need a switch. Okay, this is the probe. We just connect, we just check on this, only this part of the multiplexer. So we need a fixed voltage source here, and then we also need a ground connection for here, and we need 2 select lines. So we will just use this fixed voltage source as the select as a select lines for this. Now there are 4 inputs here. Okay, we can either use 4 input supplies here, fixed voltage sources, or we can even use the DIP switch. Now there are 8 switches here. I will just convert this into 4. I don't need 8, I will just take 4. Okay, so here we need just 4 switches. Okay, so we just connect this switch to each and every input of this, of the fixed voltage source, and then connect this part. So this is much handy. Instead of using 4 voltage sources, we just use 1 voltage source, and here to this is the A line select line, and this is the B select line. Now for this purpose, for this particular IC, this 1E and 2E, they should be grounded because they are active low, and here we connect this as the output. Now let us see the working. Okay, I'll just turn it on, this running state. Okay, and if I turn this on, okay, so with this as select lines as 0, this select lines are 0 0, so this one is selected. As you can see, green means 1, and this black means it can just switch on and off. So this is selected. Now this, they are not selected. Okay, now if I make this as 0 1. Okay, 0 1. Now so here B is the most significant and A is the least significant, so this gets selected. For 1 0 this gets selected, and for 1 1 the last one gets selected. So this is how the IC works. This is the second part. We can even connect this switch here and also verify this working of this particular thing. Then let us go to the next IC. I'll just stop this. Now the next IC is IC 74157. So this is also of course a multiplexer. The difference is here in this case is that there are 4 multiplexers which 2 input and 1 output. So we just need one select line. So just remove this. We just need one input select line, and this is the enable line, and here we just need one. So I just go into properties and just we need just two switch inputs. So this is the these are the 2 inputs. So I'll just verify this particular part of A0 B0. The same is true for A1 B1 and A2 B2 and all the other one. Okay, so this is one multiplexer, this another one, this is the third, this is the fourth. There are 4 multiplexers with 2 input and 1 output. Okay, so I'm just connecting this part A0 B0 Y0. We can even check for A1 B1 Y1, A2 B2 Y2, A3 B3 Y3. Now let's turn it on. Okay. Now with this on, okay, let us make this as 0. Okay, now select lines is 0. So this particular line A0 is selected, as we can see. If I make it 1, now B is selected. Okay, B gets selected. So when this select line is 0, A0 gets selected, and when it is 1, B gets selected, as you can see. If we make it 0, this gets selected. Okay, so this is how we verify the working of the multiplexer. Now let us verify the Demux ICs. Now verify the working of 74139. Let's just remove this IC, okay, and type here 139. So this is 139 dual 224. So in this case this enable, we will just verify this part. So I'll just connect this enable because it is active low. We need to connect it to the ground. Then here we need switches, so I'll just remove this. We don't need this. Now here we need 4 probes actually. So one probe is already there, the second probe, the third one, and the fourth one. So we connect this to the first. So this is the connection. Now this output is active low. Okay, so I'll just turn it on. Okay. So I'll just make this switch as 0 0. Now with this 0 0, what we observe is with 0 0 this gets selected. So whatever gets selected becomes low. So because this is active low. Now if I make it as 0 1, sorry, this is 0 1 is here. This is 0 1. So this gets selected. For 1 0 this gets selected, and for 1 1 this gets selected. Okay, so this is how this particular Demux IC works. So 74139. Now let us go to the last part. So we need to select the multiplexer IC. So we just type multiplexer and select. So here we have so many IC. So either we can go into IC74 series, and here we can find there are many multiplexers. So I select this 74151. So this is, I select this. Okay. So you can see there are 8 inputs. So then what we need is just cancel this out. We need input. So we take this fixed voltage supply to give the inputs if you want. Then for this S0, S1 and S2, we again need okay, what we do is we select some switches here. So this, I take this switch for S0, this for S2, S1, and then S2. Then we connect this directly to the power supply. This is S0, this is S1, and then we have this S2. Now for our function we need 0 2 5 7. A function 0 2 5, so you can check the text. So I will just connect this 7 to directly, I just turn it on and keep this 7, then 5, next is 5, then 2, then 0. So this is 2, and then we have the 0. Now the rest remaining we need to connect to ground, so I just select this ground here and connect this ground with all the remaining lines which are not there in the function. One more thing, this IC also has an enable line. As we can see, there is a bubble here, so it means it is active low, so we need to connect it to ground, otherwise it will not function. Now there are two outputs, Y and Y bar. So Y bar will give the complement, but we don't want the complement, we directly want the output. So I just take the probe here and connect it here. Now we can just turn it on. Okay. So for 0 0 0 we are getting high, that means of course this is selected. Now for 0 0 0 1, okay, we are getting 0 because this is 0. Then for 0 1 0 we are again getting 1. Okay. So whatever cell numbers 0 2 5 7, they will turn on, and the remaining will become 0. Let us check for 7. For 7 it means all should be 1, so all should when we are getting output as high. So we can verify from the truth table. I have mentioned the truth table in the text. I am sharing the text, the link for the text of the PDF file in the description section of the video. You can copy it, get it from there. So just verify this table. So for 0 0 0 we must get 1, for 0 0 1 we get 0, and so on. So this is how we implement the expression using multiplexer. Now let us go for the second part, that is the demultiplexer. So for the second part we need a demultiplexer IC. So we can just type here demultiplexer, Demux even will do, demultiplex. So we get this many number of demultiplexer IC which are available in this particular SimulIDE. So I'll just go for this one. So this is what we get for this particular IC. Now in this particular IC we have this A0, A1, A2, they are the select lines. E1, E2 and E3, they are the enable lines. So these two are active low and this is active high. We need to connect this two to the ground and this one to high, and this we just go on selecting and we get the output here. So let us select first the fixed, we get the fixed voltage. This is the fixed voltage supply. Okay, now because this select lines can be 0, can be 1, I'll just need 3 switches, so I just keep one switch here for A0, then one more switch A1 for A1, and the last one for A2. So we just connect the switch, one of the ends, and then connect this one, the third one, and this one to A1, sorry, A0. And the last one. Then one more thing, we need to connect this E3 to the power supply, and then this two we need to ground them so that they are enabled. Now the output, how to connect the output, there are two functions. One is f abc is sigma small m 0 to 4, other is 1 2 5 6. So what we do is we first of all take a OR gate, we select an OR gate. So this is the OR gate, and we need, actually this is the 3 input OR gate, so I just increase this input 3. We need one more OR gate, and there are 4 inputs in this case. So just connect, click here and input 4, and then we need a probe, so we'll just connect the probe here. This is the probe for the first function, the probe for the second function. Now if you see the function for the first case, we have 0, 2, 4, so there is 0, this is 2, and then 4, so this is done. Then second is 1, 2, 5, 6, so this is 1, this is 1, then 2 is here itself, and then 5, and finally 6, and then we connect this probe. Okay, so we are done now. We can just turn it on. So just turn it on. So for 0, all 0, 0, 0, we only have function 1. So in function 1 we have 0, 2, 4, so this glows for 0. If we make it, if you want to make it as 2, so 0, 1, 0. So for 0, 1, 0, 2, we can see in function f1 there is 2, and in 1 also, in 2 also there is 2. So for both cases we get this. And suppose if I make it as 1, 1, 0, okay, 1, 1, sorry, this is 1, 1, 0 is this one, 1, 1, 0. So in this case 1, 1, 0 is 6. So this is only for the second function. So you just verify this, giving the inputs, changing this select lines, and verifying both the tables for f1 and f2. So that's all for this particular session. Thanks for watching.